And that objective, we leverage technology to understand human behaviour in mobile and other digital contexts. Working in agile, fast-paced development environments means that we have found new ways of accurately undertaking research and communicating it effectively. So today I'll show you how we use online methods to quickly find people to test with, how we use technology to deliver irrefutable behavioural research findings that explain how poorly designed products work, why this occurs, and exactly how you can fix them. And also, I've got a little gadget to show you a video of that can be used when you're testing in a simulated environment. But first, just something fun. This is a few clients of ours. I'm excited about the next one. So, how do we find people to do testing these days? In the past, we've been pretty frustrated with participant recruitment and services that we've had across Asia Pacific, in Australia, Singapore, and other countries in the region. So we decided to set up our own. With Research Network, we were able to recruit participants very, very quickly using social media and using our website and a whole lot of surveys and a very long process that we've got to ensure that the right people turn up through rigorous screening. But something that Facebook released very recently has allowed us to do this even faster and even more accurate. So we've developed a new product called Haystack, which allows us to have 1,000 times greater reach with research participants who are on the biggest panel that exists, called Facebook, or social media, or even LinkedIn. And we get fresh participants for our testing every single time. On Facebook, we can use thousands of different data points about each of the people who are being tested, where they are, where they've been, whether they attended MRMW, major life events they've had, food they're currently eating, all sorts of things. So this is just another thing for you to think about. I think the theme of this conference is about how we can use new technology, and this is something that we've found incredibly useful in order to find the right people very, very quickly. And it's been very successful with these clients since we developed it. So the main thing I like to talk about is eye tracking. You may have seen our eye trackers out there in the booth over the last couple of days. And eye tracking is a neuromarketing tool which provides us with a valuable way to get insights into how people do things. Because it's very unobtrusive, the data is very easy for everybody to understand, both the researchers, the participants who are looking at their own data, and also the customers and the bosses who need to understand what we've discovered. So it provides accurate, detailed, additional insights into behaviour and a lot of visual stimuli, which helps to, I guess, win them over. So it can be used in usability testing, market research, shopper research, and something that I've chosen to talk most about today is in the assessment of digital things. So who's seen this image before? A couple of people? This is something I did quite a few years ago. Tobii Pro, the company in Sweden that we represent, created the image, but I actually did the data collection. So we tested people with an eye tracker, 106 of them, looking at these images. There's 2 images here, so we looked at them in a random order, and we had other ads in between. And each of the images was shown for 5 seconds. So what people did is they started looking at it in the middle of the screen, because on the prior screen there was a little cross, so people looked there because it attracted their attention. And then you can see on the left that people are moving in fixations as they go up towards the child's face. So you can see 1, 2, 3, 4, 5, 6 on the 6th one's on his ear, and then they go over to the headline. So that fixation indicates that the person's eyes have stopped long enough to process what they're looking at. So something like 600 milliseconds of time they've stopped there In between those dots are lines called saccades, and those saccades, the vision is suppressed. So psychologists say or assume that if somebody is fixating, they're processing that data. What you can see on the right-hand side is that people have stopped 4 times before getting to the headline, so the baby's guiding attention. When we look at these images, which were shown randomly for 5 seconds each, and we combine them across 106 people, we get this. And what that indicates is that people on the left are focusing on the pretty baby's face, the cute baby, and on the right, their attention is being drawn to the context, to the text, and to the logo down the bottom right, which is achieving the advertiser's goals. So this has proven very interesting for the design community because they realise that they really need to think about how faces are used in advertising. The baby that's looking out on the left might be nice if that is a supermodel advertising a particular type of clothing and the advertiser wants to associate that person with the brand. Whereas on the right, we can drive attention within the ad. We've got some other examples of this if you want to have a look later on. So what does this tell us about human behaviour? Well, conventional methods are accessing people's conscious experience, the stuff that they remember or the stuff that they make up when they're interviewed. Whereas with eye tracking, we can access people's unconscious behaviour very easily because people's eyes respond to what they're looking at instantly. So the main methodology that we use for this type of research is called retrospective think aloud. After somebody's done a task, whether it's on a website or they've been looking at a pack design or they've been looking at a poster or they've been walking around in the supermarket with some eye tracking glasses on, we show them immediately afterwards what they did, and they can see the trace of their eye on the screen, and then all of a sudden they can explain to us what they were doing. So that's a couple of different types of eye tracker designs that we leverage. Now when it comes to testing mobile apps, we can do this qualitatively or quantitatively. What you can see here is an example from some research that we did with a very large airline from Malaysia, and on the left-hand side is the usage pattern shown by the person's eye gaze of how they started to book a flight. Now on the right-hand side is somebody who's already done it. So they have less movement, they take less time, and they can get it very, very quickly. And this is the type of thing that we'll see when anybody uses an application the first time. What we want to do is make sure that the jump from the left to the right isn't so hard that they don't use it at all. So when we did that testing I showed you then, we used this type of stand here that Mick's sitting in front of, and there's an iPad on the holder that he's touching. Just below that you can see the eye tracker, which is by his knees there. That's capturing a reflection from his pupils. And then a video camera on top of it is looking at the interface that he's using and where his fingers are, so we can understand how much they're moving as well. And the eye gaze is then overlaid on the video of what he's doing so that we can see the image I showed you previously. Now, if we're doing this type of testing on a mobile device with a pair of glasses, we get a very different view. So this is a test we did for Google. We tested with more than 100 people in their homes in Sydney, and we had them undertake whatever they were going to do in the night time. But the brilliant thing is they took the eye tracker home and calibrated themselves, and there was no researcher around. So the research biases were very, very low. And I know you're all thinking, yes, but they were wearing some glasses while they were playing with their cat. So their behaviour is going to change. Now, we didn't scientifically research this, but we know people forgot they were wearing their glasses because they did some incredibly funny and illegal and silly things, like talking to their cat. Would they do that if they thought they were being recorded? Or would they put their password into their mobile phone? So of course we don't know who this person is, so it's fine. My staff do, but that's all confidential. So we did this project with Ipsos, with Google, and then it was repeated around the world. The sorts of data that we could get from this with some manual coding was understanding about males and females and the types of time they spent doing things and where advertising was relevant, where they watched the advertising, where they avoided the advertising. Of course, we made sure that they watched channels that had advertising on it and didn't watch videos that they'd pirated off the internet. So that's another example. Now, what we can also do is look at live shopper studies. And here I wanted to focus a bit on how we can do cross-platform interactions, not just necessarily buying something off the shelf. So I've got some examples here. This is at the Visitor Centre on Orchard Road. This is the type of visualization and detail that we can see from using the glasses. Here using a touchscreen. I've stopped it short, but the rest of this video has the interaction she had with the customer service person. It's a little bit harder to analyse the data coming from this type of research than it is on that mobile stand, but the trade-off, of course, is whether you're in a lab or in the real world. So another example here is for digital appliance testing. So this is actually done in Thailand, and you can see on this screen a digital touchscreen with a mock-up of a new display panel, and we put a little hardware device on the left there. That circle is simulating the washing button that you dial, that you turn. But we can see, I guess most importantly here, when we're doing this on a concept, we can see where people expect things to be before they tell us about it, because we see immediately where they look. And with this type of transactional interface, it's very important to understand the order in which things are presented and the expectation that the customer has of that order. If the order's wrong, that's where usability falls down and they get frustrated. So it's very important to test this over and over again. So it's a very popular way of doing this testing, of doing this design, I suppose. So just a quick look into the future, something that we're very excited about. We had one of these devices in the office last week, but the Swedish guys from Tobii had to take it back because there's not very many of them around in the world. But we can use a HTC Vive VR headset, and Tobii have built, retrofitted an eye tracker into each of the lenses of the HTC, and then this is the sort of thing that we can see. Now the great thing with this is, because all of the points in the Unity environment that's coded are known, the data, the heat maps and the gaze directions and everything is available instantly, already, straight away. So you can see what people are doing live, and you can also see all the statistics immediately. So once people can build Unity environments in a really cheap and fast way, they're a bit expensive at the moment, this will be a common way to test different pack designs or different store layouts or planograms or category design, that sort of thing. But the quality of the visualization is amazing. And if you try to do virtual reality research or try to understand what people are doing in that environment, if you can't see where they're looking, it's almost irrelevant, because you can see a very large field of view. The other thing you can do with this, from a gaming perspective, is you can use the eye gaze data from the VR to control the interface. And so, yeah, I think we're going to see some fancy changes in that. A very large eye tracking company was bought by Apple a couple of days ago. So augmented reality will have this type of interaction in it soon. Tobii, the guys in Sweden, are currently building millions of mobile phone handsets in China that will have eye interaction. Instead of having to use your finger, you'll just look and then you'll press a button to select things. So eye trackers are going to become part of your daily interactions, and they're also going to be part of your new research battalion, or your battery or your toolbox. So understanding the power of gaze is going to be something that I think all of you researchers will be needing to use and will be asked by clients to use in the coming years, not that far away. So thank you. Any questions?
Any questions?
Down here.
Hi, my name is Tina. I'm from Stratos, Malaysia. Just out of curiosity, have you used this kind of technology for tracking like traffic, as in like cars and all that, number of cars passing by a certain place or number of pedestrians
So
passing
these
by
are
a certain place.
the eye trackers are worn
Yes.
on a participant
Correct.
for an individual depth interview.
Right.
So we're tracking where they're looking. We're not automatically tracking anything in the field. So
In the
yeah,
field,
yeah.
so you can't track anything like in a particular sort of like up to a certain distance?
You can. Well,
Yeah.
this is tracking wherever you look, so it can.
Okay.
There might be some parallax errors in a distance,
Uh-huh.
but you could build software that tracks the number of cars that goes past a person, but I don't think that would be a good spend.
Not a good application
No.
for it. Okay, thank
Yeah.
you.
Any other questions? I think he's got one more book left. I thought we are finishing before lunch.
On at the back.
Hello, hi James. I'm from Google and I'm heading the Greater China research. And I have used the Tobii, the eye tracking device before for the research.
Mhm.
And thank you for this great technology. So my question is, I think you have convert from what people claim to the survey to the eyes, what they are looking at. But the next step is from what they are looking at to what they are really see. Because sometimes when I look at my mobile, maybe my eyes just randomized to look at different parts. But how to evaluate the quality information intake to analysis? So that's my
there's a
question.
couple of ways you could do that. I'm sure some of you have seen Cool Tool out there. Now that's doing when the person's sitting down in front of a screen and it's measuring some other neurometrics that can indicate cognitive processing. So that's one way. Those tools are not particularly mobile yet, and there's lots of noise in the data if you are wandering around or if you're sitting in an Uber and trying to do things. So give it a few years and we'll be able to do that. But for us, and when we do research, the way that we understand that data is to replay to the person who's been doing the experience in the test what they did and interview them about that. So you can say, oh, you were looking here and whatever, why? And they will explain it to you. Yes, it's a post hoc thing, but we hopefully will get some insights into what they think they were doing because they're the ones who are going to know. One of the things I get frustrated with is that many academics don't do that when they do their research. They assume and they create a hypothesis and then they have a whole statistical method to validate that, but they don't necessarily talk to the people who are doing the test to find out what the hell they were doing because they'll tell you. And if you get 10 out of 10 people telling you that they were doing the same thing, you've probably got a good finding, right? So replaying the data is the best way to do that right now. I think there'll be other ways in the future, but it's particularly outdoors and in the real world, it's a very noisy environment for all the other measures.
Any other questions?
Just thinking about what we have gone through since morning and trying to understand it better. I'm Gaurav from Tetra Pak. Do you see, because I'm a bit confused now because we have eye tracking, we have neuroscience. Are they both merging towards something, and with you exposing VR and AR maybe combining together? Is there a future where both of these merge and the indicators we have, the metrics we are measuring, they merge together and from a research perspective?
They have already merged in academia. So I've been doing eye tracking and working with academics in eye tracking since 2007. And when we started, they just did eye tracking. Then after 5 years, each of the academics has published a couple of papers. They're bored with eye tracking, so they start doing EEG, or they start doing GSR, or near-infrared spectrometry. So they start to do this. But what I've found, and we hosted a conference in Australia in 2011, and it was about EEG and eye tracking. And basically what they said is it's really, really, really hard, and it's going to take a while to be able to put them together because the EEG is very complex. So other people globally will combine different simple, like heart rate or GSR, simple neurometrics to understand what that can predict about behaviour and experience. But it's the hot topic, but it's still difficult.
Thank you, James, for that wonderful presentation.